So imagine this. You are part of a team that is responsible for maintaining a mission-critical system inside your organization. And this system was so important for the company that enables the company to scale to hundreds of developers working together in this massive application. Obviously, yes, there are some benefit of doing that and having all these great work done by developers, but there are also some challenges. So now instead of deploying like you were doing in the past multiple times per week, now you deploy once a month. And maybe the testing life cycle takes tens of minutes before are fulfilled. And sometimes when you are deploying, you need to roll back because there are many issues. Does it sound familiar to some of you? Cool. It's familiar also for me. So I work a lot in this kind of application, and I understood the benefit of leveraging distributed system where needed because an architecture is not forever. And during this session, we are going to see how Booking.com have done through this journey of modernization, leveraging serverless in order to overcome the challenges that I described before. My name is Luca Mezzalira. I'm a serverless specialist solution architect, and today with me there is Sarah.
Hi everyone, my name is Sarah. I'm a solutions architect based in Amsterdam, the Netherlands. I am passionate about observability, resilience, and serverless.
And Zishan.
Hi, I'm Zishan Pervez. I'm engineering manager at Booking.com. My team was responsible for modernization of legacy, 20 years old legacy reservation system at Booking.com.
Perfect. So let's start. But before we start, we need to understand what distributed systems are. Very often you see a lot of great definition, but for me the best one is this one. Distributed systems are living systems. If we enter in the mindset that the distributed system will require attention, care, and we start to iterate over and over again, challenging sometimes our decision, we are halfway through to the success. Usually when you embrace distributed system, you want to reach specific goals. The first one is organization scalability. You want to have the possibility to plug a new team or a partner inside your system to accelerate the delivery of specific function potentially. You want to have business agility. So if something happens internally or externally or inside your industry that require a drift towards a different direction, you will be able to make it because you just need to change a part of the system. You also want to have a faster feedback loop. I think many of you have heard about DORA metrics, and these are metrics that enable to succeed in this very complex world. But more importantly, you want to reduce the external dependencies for teams, because the reality is when you work in a monolith and you have hundreds of engineers working together, you understand that at some point you have to slow down because there is a lot of coordination. So you want to reduce the external dependencies, you want to decrease the cognitive load, and finally, you want also reduce the blast radius. So when you deploy your application or service, if that service goes down, it doesn't impact the entire system like it happens in monolithic systems. And I think in order to achieve that, you need to leverage modularity. But let's try to understand what modularity means. It's the quality of consisting of separate parts that when combined form a complete whole. But most importantly, a system lacks of modularity when a tweak to one of its components affects the functioning of others. This is not something that you can find on the tech side. This is from Cambridge Dictionary. It's the definition of modularity that is applying to everything, right? So modularity in our case can be expressed in different ways, maybe using code. So you leverage a strong encapsulation. You use design patterns that we have seen for decades working pretty well. But then at some point when you have, let's say, a decade of software that is there up and running, these kind of things can start to be diluted. You decouple the business logic from the environment, maybe using hexagonal architecture, but you need to be disciplined in the development teams. And teams sometimes are changing. People are leaving the company, moving to other teams, and so on and so forth. Therefore, modularity using code can be done, but it requires a lot of discipline. On the other side, you can apply modularity on the infrastructure level, where you have more option to express your intent. As an architect, I want to use synchronous and asynchronous programming when it's needed, because that enables me to have a more resilient system and also a scalable system. You configure more than coding, so because there are a lot of built-in behaviors that are available inside the serverless system. But more importantly, you have more control on what you develop, because you develop only a chunk of the system, and there are certain behaviors that are already built in inside your services. Because what we think in AWS is that serverless change is not anymore associated to Lambda, but is a strategy. A strategy that enables you to remove the undifferentiating heavy lifting that we take the burden on and enables you to maximize your business value. That is not writing code, but generating value for your users and your customers. And that's for us what we do day in, day out. Because when you embrace serverless, what you focus is just a little bit of defining the API and defining your business logic. All the rest, it will be taken care by us. You select the right service for the job, and you will be good to go. So what we are witnessing with customers, and let's say I usually touch between 50 and 100 customers every year, a paradigm shift. In order to win new customers for them, we need to build better products. And therefore, it means we need to innovate more often and be advanced compared our competitors. We need to release feature faster because that's the only way to test our assumption. And therefore, the DORA metrics comes very handy in this case. And therefore, you need to focus more on the business logic and the couple software systems. So serverless seems like the perfect fit of what you need to do. And serverless very often is thought in a way that, you can do only event-driven architectures. But it's not true. With serverless, it's just a tool. You can express wherever architecture you need. You want to be point-to-point using microservices and HTTP response, you can do that. You want to use event-driven architecture because a part of the system, like we are going to see later on with Sarah, is benefit from this approach. You will do that. You can use also for data architecture. Very often I have customers that are using serverless services for ETL or for, let's say, drawing data towards the data lakes. And you can also use it at the edge of your architecture and its integration patterns that I would say is one of my favorite ways to use serverless, because you know better than me that SaaS products very often have a lot of quotas that we need to be aware of, and you cannot just hammer it every second with the same throughput that you have inside your system. So these kind of things are, let's say, patterns and architecture you can use in serverless. But now, without further ado, let me introduce you to Zishan that is going to start the discussion around how Booking.com embrace all this goodness.
Thank you, Luca, for explaining the foundational concepts of serverless and the associated architecture patterns. So my name is Zishan. And for the last 3 years, I've been working at Booking. And the target of my team was only one thing: to modernize our reservation system, which was 20 plus years old. It was a mission-critical system. But before we start, let me ask one question. How many of you have booked a trip through Booking.com? Okay, I see some hands. Thank you. Thank you for choosing our platform. At Booking, we believe life is made of experiences. Experiences we share with each other, experiences both big and small. And that is why millions of customers each day choose Booking.com as a platform to experience the world. Therefore, our mission is to make it easier for everyone to experience the world. At the core, it is powered by Booking.com's mission-critical reservation system, which handles millions of reservations each day. At scale, to stay competitive, we need to deliver features faster, and the features should bring some value to the customers, but also quickly and reliably, so that they can enjoy their experiences. However, engineering teams are under constant pressure to improve the time to market or reduce the time to market, and this puts them under a lot of pressure. Apparently not so easy for the engineering teams. So before I go into the why part of why we modernized, I would like to talk about some of the things that were really stopping us from delivering the features faster at the pace that the business demanded. So let's start with the first one. Booking.com is a monolith as it began. It was written in Perl. When it started, it was a small, cohesive, and easy repository. It was easy to build, easy to test, and easy to deploy. But as features and teams multiplied, cross-dependencies grew. Builds slowed down, tests ballooned, and the boundaries were blurred. Tight coupling made changes brittle, deployments were becoming painful, and debugging became a nightmare. So overall, it culminated it into a big ball of mud. Teams then faced a choice: keep patching a fragile monolith system, or modernize by splitting it into services. So before we look into how our team solved the challenges they faced, let's speak into a bit of what specific problems they were facing. So our legacy system had 90 plus dependencies, which included services as well as database tables. More than 80% of those dependencies were hard dependencies. That means like if there was any failure, there was a cascading effect on other services as well. This oversized web of dependencies resulted in weak modularity that Luca was also referring to. So also there was a leaky boundary in data layer. That internal data model was exposed to other services, and this caused services to erode encapsulation. And since it was a tightly coupled Perl monolith, developers added code wherever they wanted and wherever the data was available. So this introduced coupling creep. Also, there were shared data models which were used across different services. As a result of this excessive coupling and wide blast radius, a single outage would cascade and the modules can't degrade gracefully. Another challenge that we had was domain divergence. Reservation workflows and data structures accumulated logic from different domains. For example, pricing, commission, customer service, messaging, fraud, to name it a few. And the domain boundaries were blurred. For example, in our reservation workflow, commission was being calculated, which could be done independently. And in another example, reservation system was calculating charges and then writing them into a database that was even not owned by us. So it was outside of reservation domain. So many of these problems that we discussed gave rise to either shared ownership or no ownership at all. The team frequently came across problems in terms of finding the right owners, and we found a lot of dead code which was left uncleaned. This made it difficult for the team to perform root cause analysis during outages and find the owners who knew what the code was doing. Our system was running on bare metal servers, which came with its own pain points. It was a bundled logic in one giant service. Changes and rollouts were risky. And there was a lot of time spent in maintenance of the servers, for example, applying security patches, faulty server replacements, or updates. Regular manual capacity checks were required to ensure that servers are configured correctly and they can handle the load. Well, though somewhat automated, it was taking a lot of time that we could easily use in building some new features for our customers. So these were not just technical problems. They had a profound impact on our team as well. So let's look into how our teams were impacted with this. Teams spent more time dealing with issues related to ownership, which was not a fancy topic. This led to burnout, low motivation in the team, resulting in disengagement. On the other hand, it took us 4 months to onboard a new team member. And even before that, it took us like 50% of the time to just give them 50% knowledge of the domain. And there was not enough documentation, and the system was highly complex. This high complexity, unclear ownership, mix-up of domains resulted in bugs and outages, which increased the KTL of the team. So yeah, there was high KTL. All of this combined took significant energy of the team, which could have been spent building new features. So the team reached a point where they decided this cannot continue anymore. Around this time, we also received a big list of features that we needed to implement. And the team decided that the only way to sustain and the only way to be future-proof is to modernize our system. So we started looking into our future needs and capabilities required to ensure that we remain fit for the purpose. So based on the team's learning from the hands-on experience that they had in the reservation domain, we listed down some problems that the team was experiencing. And then we prioritized from those lists a couple of things that we think like we really need to work on. Some of those things were isolating unknown code, defining boundaries, removing coupling, and then with this prioritized list of things that we wanted to fix, we came up with the North Star architecture. The North Star architecture, or our target architecture, was aimed at solving problems related to unclear boundary, coupling of code, and reducing unnecessary dependencies. We came up with the high-level architecture, which was platform independent. So we didn't think about moving it to the cloud at that time, but we designed an architecture which was modularizing our things, and we were looking at different approaches for that. So once we had this architecture, this was reviewed by a lot of our internal architects, including cloud architects, as well as some principal developers. during our discussions, there was an inclination that the future architecture of the Boeing should go through the transformation phases. Instead of going from first one and then stepping to the second one and then stepping to the third one, we should really move from the first one directly to AWS managed services and reap the benefits of the cloud. One of our requirements was to have isolated flows and modular code. So when we looked at AWS, there were the step function and Lambda offerings provided what we needed. Lambdas can break logic into smaller reusable functions, and step functions can orchestrate these reusable functions into clear isolated workflows. So all of this while providing out-of-the-box functionality such as observability and monitoring. So overall inclination was to pioneer use of serverless with a mission-critical workload. But the problem was that our team had no prior experience with the cloud, let alone serverless. So hence it was not clear for the team how to proceed on this one. So despite promises from the leadership that they will support will be provided, the team was a bit skeptical about serverless. So some of them said, let's not take the risk, it's too risky. Some didn't have the opinion about it, and some said, let's go, do it. Some of the assumptions that they had was it will take too long to learn AWS, Lambda functions will create some performance bottlenecks, the cost will be too high, it will be challenging to connect to our booking internal infrastructure, and why choose a mission-critical system for such an experiment? However, as an engineering manager, I made sure that I saw a big opportunity in this for learning for the team, and I asked the team, let's do something different and make sure that we get hands-on experience on AWS. So also it was a great opportunity for our internal cloud teams to learn from a highly critical, mission-critical workload and to see that how this workload works on serverless. So after a lot of team discussions, one-on-ones, and inspirational speeches, I had to write the first Lambda to inspire the team. And following that, the team started working on a proof of concept, which I'm just going to show. For the proof of concept, we chose very simple use case to test a request coming from AWS Cloud to one of our services on-prem. As you can see, it's just a test call. The Lambda calls one of our internal dependencies, and then it gets some data. What we wanted to test was how it performs in terms of performance and what is the cost going to be with the volume of requests that we are trying to create. When this worked, this boosted team's confidence, and one of the things was clear that it would be challenging to connect to internal infrastructure of Booking.com, but we also saw very good output in terms of managed services. There were some things lacking in this proof of concept that we came to know later. For example, we were not able to test multi-region deployments, how it connects to other internal tooling, for example, incident management, service-to-service integration. But at least we got the confidence that if we move forward, it's going to work. So with the learnings from the proof of concept, the choice was made. We are going to modernize using AWS Serverless. And the proof of concept gave us this confidence that the selected solution is going to work for us. So the team decided to go ahead and create a serverless architecture. But before we look at the architecture, what were the key takeaways from the proof of concept? We saw that the team was able to focus more on the business logic because a lot of the operational stuff was handled by AWS. We noticed that our team can save 5 to 10% of their time spending on managing servers, updates, and things like that we can save. And then integrating with other AWS services was seamless. For example, we connected with step function later on. So the team spent some time and formulated a final solution on serverless, which was reviewed and approved by our cloud architects. Now I'm going to explain what the solution looks like. On the left side, you see booking infrastructure. On the right side, you also see booking services. And in the middle is the new solution, the new reservation system that we built. One of these Lambda function triggers a step function, you can see in the middle. And the step function internally had 15 other Lambdas, which were doing different things. We also made use of DynamoDB to store the request temporarily. We put a time to live on that so that the database size is not increasing. But this made it easier for us that within the step functions, we were able to access data from DynamoDB from the request whenever it was needed. And we would only select the part of the data that was required for us. Overall, it created very flexible decoupled architecture For example, we also see at the end that we have used SNS to fan out to different notifications to different SQS queues. And then there is another Lambda on the other side, which is asynchronously reading from this queue. So basically decoupling the system. Overall, this was the architecture that we created. Also, I would like to highlight here a step function execution. So if you just focus on the green blocks here, the big block at the top is a parallel execution of all these lambdas. And then you can see that after that execution is complete, then we call another lambda on the left side, which further calls another parallel block. But what is also important to see here is all these lines, which are catch blocks, basically. And this comes out of the box. So basically, the error handling comes out of the box in step function, which saves a lot of time because we don't have to maintain this code anymore. So it wasn't a smooth journey. We encountered a lot of problems, but we wanted to solve them, and we showed resilience, and they were systematically resolved. For example, one of the biggest problems that we had was lambda latency and cold starts. So I'm going to explain a little bit about the chart that you see on the top. This is a latency chart that we did an experiment with different configurations to find which is the most suitable configuration for our use case. So on the left side, you see provision concurrency with half a GB of memory. In the middle, you see provision concurrency with 1 GB of memory. And then on the right side, we use snap starts because we were using Java. AWS offers snap start as a solution to warm up the lambdas. And provision concurrency also offers the same opportunity. But we saw that the configuration in the middle was something that we can rely on. So we chose provision concurrency as our configuration with 1 GB of memory. But if you see the graph below that, you will see that results were still not good enough for us. We started at 3200 milliseconds, which was what we were getting as a latency in our lambdas. But then you see, like in the bottom, it says SDK optimizations, Jakarta optimizations, and other optimizations. This is where we optimize the code to work with to warm up the objects in Java, so that the Java initialization time is reduced, and then we get the same effect as if the lambda was warmed up. So this reduced the latency to 140, which was very good. So when the team started working on modernization project, we encountered another problem. We had only one environment to work on, and that was just our development environment. And we had 6 people in the team. So we had to work with our cloud team to come up with a new solution for creating personal environments within AWS. They worked with AWS and delivered us a solution. Before that, the team was time slicing, and basically there was a lot of communication overhead. So because we adopted this solution early on, there were some problems in it which further created problems for the team to pursue further. But over the time, the solution matured, and we expanded from 1 team to 3 teams, and at the end, 25 people were using this environment. Some of the internal booking tooling was not ready to set up the handling with serverless. There were some key features missing. For example, there was no multi-region deployment. We didn't know how to do that. And there was no clear strategy on how to do canary deployments, rollbacks, hotfixes, feature flags. All of these are essential for good operations. Also, our compliance team was a bit resistant in approving our requests for production environment because this was the first time we were doing serverless, and they wanted to make sure that there are controls in place. So that took us a couple of months of our time in back and forth explanations of how it works and what is our use case. So we had to address all their concerns to do that. At the end, we wanted to test what we built. We took a little over a year to build the architecture that we mentioned. Most of the time was spent on understanding the dependencies. We had some capacity constraints, and then there were some internal alignments. So it was not the development that took the whole time. But once we had the basic use case developed, we started thinking about how to test this. How can we make sure that this is the solution that is working, that's going to work in production? So we decided we will go with the shadow traffic approach. Has anybody here heard about shadow traffic? I see a few hands. Okay, good. So shadow traffic is an approach in which you can find gaps in functionality when you modernize a system. So as you can see in the diagram, essentially we create a copy of the request coming to production and forward it to the new service and compare the outcomes. We also followed a similar approach. As you can see, there was a mirror request created which went to our modernized backend, and at the end, the output from the legacy and the modernized backend was compared by our data quality checker. We created some script for that, and that script generated an output report which was mentioning the mismatches, and based on that information, we were able to find where there was a gap between the two systems, and there were so many upsides of this approach. Let's look at that. Shadow traffic approach allowed us to do iterative development. It helped us to test new features with confidence, so it gave us confidence to go forward. There were data quality gaps identified during this execution, and we were also able to performance tune our system because we really put 100% shadow traffic on our new system. So we scaled from 1 to 100%, and we were able to see the whole load, how is it performing, how much cost is going to take. So we kept it running for a month to understand all the problems that can occur. With 100% shadow traffic, we also got a good idea about the cost, and we were able to forecast the cost in the future. As we went live, as a go-live strategy, we used experimentation approach. This is something very common in booking. Essentially, we pass a percentage of traffic to the new system and see how is it basically different between base and variant. We wanted to make sure that company metrics are not impacted and the business is not impacted. So we took an experimentation approach because it helps us de-risk the high-stake migration, explore real-world problems earlier, and build confidence with stakeholders. So as it was a mission-critical system, we used experimentation and we scaled this traffic in stages. You can see here 1, 10, 30, 45, 90, and 100. These were some of the stages that we created. But the question was how to divide this traffic in the first place. Like how did we came up with this? So we worked with our data science team, and we went over past data to see like how we can divide the traffic into different payment timings, and this is what we use as a criteria. But of course, in your use case, you will have to find something else based on your own use case. So did we get what we wanted to achieve at the end? Was it all worth the effort? First of all, we unlocked a lot of tech capabilities for the whole organization. For example, we were able to communicate from AWS to on-prem service. Then Lambdas were able to write to Kafka topics. Also, we integrated with our internal monitoring, observability tooling, and incident management tooling. This is something that was not available before. And then also we had Vault integration for service-to-service authentication, especially when we were connecting with on-prem services. So some of the benefits that we saw were it reduced the onboarding time. New developers were getting productive very fast. Basically, the time we saw that the new developers are now producing their first MR within their first month, which used to be 4 months in the past. So this was something that we saw immediately. And of course, there were plenty of resources available. There was a lot of documentation. So it's very standard how AWS works. So that was helping us onboard people faster. It improved our developer experience. There was faster debugging due to all the tools that are available out of the box. For example, CloudWatch, metrics, X-ray tracing, step function execution workflows like I showed you before. So it was easier for us to perform a root cause analysis super fast within few hours and produce first fix MRs for any bugs that we found. All of this improved the developer experience and helped us respond to incidents faster. It also improved the time to market. This is the main metric that we wanted to hit. The agility in the architecture provides the ability to move things around quickly. In one particular example, we had to move the whole parallel block of Lambdas to synchronous. So it was asynchronous, and we were moving it to synchronous. And that took us just 2 weeks. It wasn't a big deal for us because the system was very flexible, and it was easier to move things around. So we see amazing results when it comes to improvement in terms of reduced time to market. So at the end, I would like to ask, how many of you have booked a trip to Las Vegas using Booking.com? Okay, I see some hands. So your reservation was 100% through Booking modernized system, which is based on AWS Serverless. So the team recently achieved this milestone of 100% traffic on the new system, and thereby we have decommissioned the old reservation creation endpoints. So that means all the new reservations are going through this new serverless system. This milestone paved the way for other teams to also use our platform and deliver features faster. This is the creation of reservation. We also have modification and cancellation use cases, and they are delivering their use cases very fast on the same platform. And to wrap it up at the end, I've shared our modernized journey and what we set to achieve and what were our targets. But I hope it gave you some insights into how AWS Serverless can be used for transformation, and that you will explore what fits your needs and what are your use cases. So I will leave with a quote at the end and invite Sarah to share more about serverless patterns based on broader industry experience. Sarah.
Thank you, Deshan. We just heard this inspiring story about Booking's ARB, accommodation reservation backend, how they went through this transformative journey and modernized their legacy system on-prem into a fully serverless architecture. They took the bold choice of doing this leap, but in fact, this is not the only way in which AWS customers can migrate and modernize in AWS. In AWS, we have identified what we call the 7 Rs, migration pathways. We have the retain, we have a retire, we have a relocate, we have a rehost, we have a replatform, we have a repurchase, and we have a refactor. Refactor is the main topic of today, as you can imagine, you have understood so far. And this is essentially taking the leap of migrating from on-prem to AWS and immediately, quickly adopt serverless technologies and unlock the benefits of adopting cloud-native capabilities. What is important in this slide is that there is not one that fits all use cases. Company all around the world, a different size, they need to choose what fits their use case and what makes more sense for their company requirements. The slide that I just showed you speaks about technology. But when we think about software modernization, like modernization of our architecture and so on, it's not only about technology, it's about technology, processes, and people. Think about it as a triangle. If any of the sides of these triangles are weak, this has an impact on the other aspect, on the other pillars. And it might be that in your case, in your company case, not all of these 3 pillars are perfect from the beginning. So when I say people, processing, and technology, what I mean, we need multidisciplinary teams that have a deep understanding of the technical and business context in which your company operated on-prem and will operate in the cloud. You need processes that empower people to have a fast decision-making as well as iterative progress. Lastly, you need the technology that best fits your specific use cases. There is not one size fits all. And the successes or issues that you have in one pillar may have a ripple effect on all the others, or one of the other. Let's have a look at an example, a practical example. Customers sometimes have the choice, the technological choice of choosing between a monorepo for their system or a code base versus multiple repos. On the surface, this sounds like a technical use case, right? But let's have a look at it a bit deeper. So if we think about this decision, what are the trade-offs? If you decide to adopt a monorepo, this comes from a technical standpoint with the consequence that you may, as a company or as a team, have less availability of tooling out of the box to manage this large code base. Practically, what it means is that you have to build your own specific tooling to manage this code base. You have to maintain it. You have to build it from scratch. You cannot use easily maybe something out of the box. So this is the technical part. From a processes perspective, because you have a monorepo, it might mean that you can adopt trunk-based development. This informs how your processes work. And on the other side, from the people perspective, because you have a monorepo, this can come with the consequence that you have frequent or higher touch point of merge requests cross teams. So this is the monorepo choice. But if we go with multiple repo, from a technical standpoint, we have perhaps more tooling out of the box to manage these different code bases more independently. From a processes standpoint, this means that now you may need to enforce strict API contracts to communicate between these systems. And from a people perspective, because now these teams operate more independently in different code bases, this comes with the consequence that they have not very often the opportunity to do merge requests, cross-functional or cross-team requests within your organization. There, as you can see, there is not one size fits all, and it's about choosing what fits for your use case. So keeping this triangle as our guiding principle to modernize our application, how do we transform a highly coupled monolith into a loosely coupled collection of serverless services? How do we do that? There's different ways to achieve this. Let's start with a very famous one, which is the Strangler Fig pattern. This is a pattern that takes its name from the use case of this plant that slowly replaces its host tree. So as the name suggests, this is about incremental modernization. Let's take an example of an e-commerce organization that wants to move away from their monolith and move to AWS. How would they, let's have a look at the first phase. In the monolith, they have different core functionality. There is a product functionality, product management, there is order management functionality, and then there is invoices. At the beginning, they are all on-prem. After that, what happens in the next phase, in the Strangler Fig pattern, the company identifies a use case, in this case invoicing, for modernization. And in this coexist phase, second phase, what happens is that you have a routing layer that enables and allows the two systems, the legacy system and a new modernized system, to coexist. And once the invoicing component has been modernized and moved to AWS, you have these two existing systems. The traffic is routed into these two coexisting systems. And once the first phase is successful, you incrementally move all the others until you have all of them into the new modernized applications. The next pattern that we typically identified is the branch by abstraction. This is particularly valuable when modernizing shared capabilities. This can sound a little bit similar to the one that we have just discussed before, but the first one was more about routing and coexisting on two different systems. This is about abstracting the complexity of having two implementations at the same time. So in this case, we have this e-commerce company that have, again, the product management, order management, and invoicing management functionality. All of these functionalities, we identified that there is a common functionality that all of them rely on, which is the notification functionality. Think about, once a customer buys something, there is the order email, the summary that tells the customer about the order. It can be about different things. It can be about invoicing. And it can be also telling the customer about new products that have been now in the catalog, right? So this is a shared functionality from all of this. What this pattern does is hides the complexity of having the two implementations at the same time. Then you have the decomposed by business capability pattern. So in this case, the capability could be the order service or order management, as well as functionality or so on. And in this case, you decide to modernize, and your architectural boundaries are informed by your business functionalities and capabilities. So in this case, your business capabilities become the map of your modernization. Then we have decomposed by subdomain capability, which could sound a little bit like the other one, but it's slightly different. So in this case, think about the order notification. So we have an order service that publishes an event, and then this event triggers some notifications in your internal backend systems related to different things. And while you decided to modernize your architecture, you realize that actually the business functionality varies, in this case, depending on where your order is being processed. So in the case of orders that happen in the US, you have orders that need to have different business logic depending on the state. So California may have different regulation compared to other states, and there is some things that need to be done differently based on privacy notice and customer data and so on and so forth. And in Europe, for instance, you have different business logic because you have a GDPR compliance and so on, other compliances that are related to Europe. So you, during your modernization process, you notice, oh, this is quite different. And what this means then, you decide as a company that your subdomain will inform the architectural boundaries of your system, essentially. So in this case, you have an AWS Lambda order service that publishes an event, and then you have Amazon SNS that propagates this event to Lambda base in the US, and that has a different business logic. And on the other side, you have a similar architecture on the for customers that are based in Europe, and then you can encapsulate this logic and easily change this logic without impacting the one from US customer or the other way around. Then we have decompose by transactions. So think about your order functionality again. As you try to modernize, you realize that the user experience when the customer tried to create an order is slightly different from the user experience of customer that tried to cancel an order. So as an architect or a builder, you realize, okay, when customers are trying to, for instance, create an order, the customer wants and needs an immediate feedback loop. Check. It should be almost instant. Whether when the customer decides to cancel an order, that triggers a chain of actions that take more time, and the customer doesn't need to know right away what is the outcome of that orchestration, but they just need to know, okay, that's the order has been submitted. So this different user experience informs your architectural boundaries, and by decoupling, by implementing different architecture based on the transaction, create or cancel, you can now handle the two things differently. So in the first one on the top, create order, you can have Amazon API Gateway, AWS Lambda, DynamoDB. The user creates the order, you store the data in DynamoDB bank, and we have the response very quickly. Whether when you want to cancel the order, you have to process the data, talk with different backend systems, talk potentially with other third-party systems. That will take some time. So in this case, we need an API gateway as well as a step function workload to manage the orchestration of this. Then we have team-based service decomposition. In this case, remember when I talked about the three pillars, people, processes, and technology? This is an interesting pattern because in this case, the people inform your architectural boundaries. So you have an order team that is familiar or owning the order code base and the order systems. Then you have a product team that manages the product capability as well as code base, an invoicing team, and payment team. So this is an interesting way in which you can also decompose your monolith. So we have explored so far the 7 Rs. We have seen how the triangular prefix pattern can help you, or the branch by extraction pattern can help you decompose the monolith. But there is also another crucial aspect of modernization that deserves our attention, which is how our services communicate with each other. So think about, as we break our monolith, how can we rethink the way that our components talk to each other in a way that improve our customer experience as well our team communicate to each other. Remember the triangle, it's about processes, people, and technology. One of the key aspects about adopting serverless is that you can challenge your own assumptions about user experience and how your system should communicate and how your teams could communicate to improve and your overall, customer satisfaction and time to market and so on. So let's go back to the example of having a e-commerce organization. Let's say that once that your product team comes with an idea that you want to implement a new gift code functionality. So your teams need to implement a gift code service. This gift code needs to be communicating with other third-party gift code systems within other SaaS vendors. You have to, this gift code need to be attached to internal systems, like for instance, your user account needs to be attached to be redeemed. And then to validate this gift code in real time, you need to have like the CRM system, external system that validates this gift code. So in a synchronous world, what could happen? Think about the holiday season, high season. From the customer perspective, a customer goes to your website, an e-commerce website. They try to redeem a gift code. And this process of validating the gift code and redeeming the gift code is usually synchronous, potentially synchronous. But this is a problem in high season or like a peak period, because your CRM might be external CRM that you have no control over, might be a bit in difficulty. So the response time is a bit longer, which has an impact potentially in a synchronous world on your own system, as well as an impact on the user experience of your own customer. That is not great. How can we rethink? How can we leverage AWS serverless services to rethink how this could be architected? So here is where serverless shines with asynchronous patterns. When a gift code is entered, we immediately save it to DynamoDB, Amazon DynamoDB. DynamoDB streams then trigger the event bridge pipes, which handles the event propagation. Then this system needs to validate the code across multiple external systems, our loyalty program provider to check the point balances, think about also fraud detection and so on. We need to verify legitimacy and so on. After that, we can rely on event bridge pipes to then transform the payload to make it compliant to the CRM format that the CRM needs, right? And if the code is invalid, then we can notify the customer through the existing notification service. And the customer, in the meantime, which is very important, can enjoy the instant response and continue shopping, because at the beginning, we have that synchronous feedback loop. In this case, and this is crucial, we're not saying that everything should be asynchronous. This is very important. The beauty of serverless is that we can mix these patterns, right? So we use event bridge pipes in this case for asynchronous gift code validation and enrichment during the shopping part, but then we switch to synchronous API calls during the checkout part, right? And only when we absolutely need it, that immediate conversation. This is not only about implementation. This is about rethinking our assumption about user experience and system integration. So sometimes the best solution is letting go of that immediate consistency in favor of eventual consistency when the business context allows it. And then lastly, pipes enrich the event with user data from our internal user management service. So again, going again through the flow, we have Amazon API Gateway, AWS Lambda, DynamoDB that handle that synchronous part, improving the customer experience. And then we have that event propagation to event bridge that handle the asynchronous experience. And that allows us to rethink again how our system works, how the customer experience should be, how our teams should cooperate with each other, what they own, and how can modularize these architectures so then we enable faster development and better experience. So as we wrap up today the discussion about modernization, let's kind of recap what we have discussed so far. So, as Luca said initially, distributed systems are living systems. What it means is that they are not static. They are not immutable. They evolve and grow because your company, your organization evolves and grows. Your processes change. Your people evolve as well. So in this case, we have realized through the seminars and also through the inspiring story that Zeshan shared about ARB accommodation reservation backend, that we can think beyond lift and shift. We can think about serverless not only as a technology, but also a key strategic decision in this case. And in this case, we also saw, while decomposing the monolith and the patterns, what are the hows? So for instance, Strangler Fig, and what are the what that we can decompose and modernize? Think about decompose by business capabilities. And at the end, we have understood how we can unlock asynchronous communication in our systems and challenge our own assumption by using AWS services like DynamoDB, EventBridge, Lambda, API Gateway, and so on. Lastly, I want to conclude this session with something really important, and I want you to bring with you back home. Grow, not build software. Software is not immutable. Software evolves. Thank you so much.